Hey guys, if you are in trigonometry, this is from 7.6, and if you are in pre-cal, this is from 6.6, and we're going to start talking today about vectors. I'm splitting up this lesson into two videos, okay, so there will be a part 2. So vectors is something this is the first time you're hearing about, so I'm going to start you off with some vocabulary. In my own class, I usually start off with a video from Despicable Me. The villain's name is Vector, and he says he's committing crime with both direction and magnitude. And so you can always check out that little clip and it'll help you remember. But a vector is a quantity with both direction and magnitude. The easiest example that I usually give my class is a car. A car has a vector. It has a direction. Let's say you're on the highway going north. North is your direction. And then your magnitude would be the quantity or length or speed that you're going. So you could say that your magnitude is either that you traveled 10 miles, or you could even say that your magnitude is the fact that you're going 50 miles an hour, 60 miles an hour. Okay? So you can say that two vectors are going to be equal when their direction and their magnitude are equal. Okay? So let's take a look at these visuals down here. These two vectors are the only two out of these 4 scenarios that are equal because they're going in the same direction and their magnitude, their length, is the same. Now look at these three. These three, the vectors, vector v and vector w, are not the same. So here let's say that their length, their magnitude is the same, but they're not going in the same direction. Here they look like they're identical, but the arrow indicates that they're going in opposite direction. And I'll talk a little bit more about that drawing in a moment. Here they are going in the same direction, but their magnitude, their lengths are different, okay? So now scalar has to do with magnitude, but no direction, okay? So when I'm talking scalar, I'm not worried about the direction, just the magnitude. One example that's something that is a scalar and not a vector is your thermometer in your house, okay? If I put the temperature at 73 degrees in my house, that it has a magnitude, it doesn't necessarily have a direction, okay? Now, the way that we draw vectors is using a directed line segment. Now, this looks a lot like a ray, a combination of a ray and a line segment, which you learned in geometry. So, a directed line segment has 2 dots to tell you from where to where what the magnitude is of that vector. And then it has an arrow to indicate its direction, okay? So a ray in geometry wouldn't have this dot and it would indicate that it was going on forever. And a line segment in geometry wouldn't have the arrow because the direction wouldn't matter. So we would call the point without the arrow the initial point. And then the point with the arrow be the terminal point, meaning where you're going up to. This would be considered point 1, and this would be considered point 2, okay? So again, we said magnitude is either the length or the distance of a directed line segment. We'll learn how to solve for that in a moment. The notation, anytime I ask you to solve for the magnitude, it looks like 2 absolute value bars around the letter representing the vector. So most of the time you'll see a V for vector. If there's more than one, you'll see them move on to W and things like that. But if they ever want the magnitude, the length, the quantity of that vector, you'll see those 2 lines around the letter V or W or whichever it may be. So let me give you one more visual representation. Scalar multiplication. We said scalar has a magnitude, okay? Scalar is going to work a lot like multiplication and distribution. So if I ever want to multiply a vector by 2, you just literally double the size of the vector. Its magnitude, its length. So if this was vector v, 2v would be double the length. We don't change the direction. And if I were to say negative half of v, negative changes the direction to the opposite side, and half means you just cut the length, the magnitude, in half, okay? Now, this next portion here is probably the most important part of vector information. So vectors can be in general form or standard form. Our main goal is going to be to get it into standard form, which is called an IJ unit vector. Maybe you'll hear the term an IJ vector, or you'll just hear the term a unit vector. That's some vocabulary you might hear. So let's look at general form. If it's given in general form, they will give you 2 ordered pairs. they have to indicate who is the first point or the initial point and who the second point or who the terminal point is. Okay? Those are your two ordered pairs. Now, the distance between these two x's will tell me the length of the unit that goes in front of I. So if I were to subtract the two x's, we'll call that A. And we'll see that because of the writing over here. That would tell me the number unit that I would put in front of I. Now the difference, the distance between the y's, if I subtract my y values, will give me B, which is the distance that I'm going to put in front of J. Okay? And that is how I will write my vector. Let's look at how the vector notation looks in standard form. Standard form is nicest because that one ordered pair is going to be your A and your B because I start at the origin. Okay? The most standard, common, clean way to write a vector is AI plus BJ, where A and B represents the X and Y coordinate. One of my favorite things about math is that they always keep everything in alphabetical order. So just like X comes before Y, A comes before B, and I also comes before J. Everything stays in alphabetical order. All right? So that is how you were to write the vector if it was in general form or if it was already nice, neat, and in standard form. Okay? Now let's look at how to find our magnitude. Remember that symbol with the two absolute value bars means magnitude. If I want to know the length, the magnitude here, it is also known as the distance, I can use the distance formula, which is square root of the difference of the x's squared plus the difference of the y's squared. Okay? Now we had said that if we subtract the x's, we would get the A, which is why this is simply A squared. And if we subtract the y's, we would get B, which is why this is simply B squared. Okay? Which, when you clean this up, this ends up giving you Pythagorean. So check it out. Just a little extra side note. This right here makes a right triangle with this line, the vector being the hypotenuse. So A squared plus B squared equals C squared. If I wanted to isolate C, I would just do the square root. And that's how we get this, okay? So no stress of having that memorized. Just know that if it's in standard form as an IJ unit vector, we can go straight to Pythagorean. If it's in general form, we're going to have to do distance, or you can convert it first and then do Pythagorean if you feel like that is shorter. Again, standard form, that IJ unit vector is our goal. So let's start looking at some examples. We had said that we know two vectors are equivalent if their direction and their magnitude are the same. So this first question asks us to prove that the magnitude of U and V are the same. Let's say this one here was U, okay, and this one here was V. So U is in standard form, and I know that because it stems from the origin, okay? So if I want to find the magnitude of vector U, because it's in standard form, I can use Pythagorean, and I would say the square root of 2 squared plus 3 squared. Okay? And I'm done finding the magnitude of vector U. Okay? Now let's compare it with vector V. Vector V is in general form, giving me 2 points. The initial point, and here is the terminal point. Okay? So this would be distance formula. So that would be the difference of the x's. I would say -2 minus a -4 squared plus the difference in my y's, which would be 1 minus a -4 squared. Okay? These two negatives make a positive, so -2 plus 4 would give me a -2 squared, plus this would give me here, 2 negatives make a positive. I apologize, this should be a -1 over here. which would make this one also a negative 1. So negative 1 plus 4 gives me a 3 squared. We keep our square root. So now I have square root of 4 plus 9. And to be honest, I know this is going to give me square root of 13, but the moment you catch that you have something that is equal, you have proven that their magnitudes are equal, okay? So the fact that this happens, we can say therefore, these 3 dots in a triangle mean therefore, the magnitude of u is equal to the magnitude of v. And you'd be done with this problem, okay? So I specifically picked these 2 points first. So I did the negative 2 minus the negative 4, and then I did the negative 1 minus the negative 4. So we know that this is a terminal point and this is the initial. The next question poses the question of, does the order that you choose matter? Okay, well, let's check it out. Let's call this vector v. Okay. So let's go from A to B first. So 6 minus 2 squared plus 4 minus 3 squared. Okay? Or if we write it the other way, we would say 2 minus 6 squared plus 3 minus 4 squared. So if I go from point A to, this one here is from A to B, and this one is going from B to A. Okay, so hopefully you guys are starting to grab the concept that if magnitude is just the length, whether I go from A to B or B to A, should get the same answer. Let's double check. 6 minus 2 is 4. 4 minus 3 is 1. Okay. Here, 2 minus 6 is negative 4. And this 3 minus 4 gives me negative 1. So remember that these parentheses are a big deal. If you're doing this in your calculator and you forget these parentheses, you'll get the wrong answer. Your calculator is so good at doing PEMDAS that it'll do the exponent before it multiplies the negative. But it is the entire negative 4 that gets squared, okay? So you should end up with the exact same answer. Yep. So order does not matter, okay? For magnitude, that is. Let's go ahead and move on up. So the next question says, sketch vector v and find its magnitude, okay? Let's start off by noticing that vector v is given to us in standard form, okay? Remember, this is an alphabetical order, so this first number in front of the I is my A, negative 2. That's going to represent my X. And then this number in front of the I is just a 1. So I'm going to plot that as negative 2 on the X, comma, 1 on the Y, okay? And then I'm going to connect that to the origin and make sure that my arrow goes towards that point, okay? So now my next step is just to find the magnitude. Because this is in standard form, it is an IJ unit vector, I can go straight to Pythagorean. Square root of negative 2 squared plus 1 squared. This gives me square root of 4 plus 1, which is the square root of 5. Okay? So I have my sketch of my vector in standard form, and then I have my magnitude. All right? So this next one is a little more complicated. There's going to be a little more work to do. It says vector v exists from initial point P1, which is negative 2, 2, to terminal point, point 2, 2, comma 3. Okay? write V in terms of ij, so we're going to convert it over like this one was. Find the magnitude and sketch both, okay? So if I wanted to sketch this one, let's start off by sketching it. I have -2, -2, so 1, 2, 1, 2. Here's my first point. And then I have +2, comma 3. Okay, and that point would end up around there. So they told me this -2, -2 was my initial point, which means that my arrow goes on this point, my terminal point. Okay. Now let's go ahead and write V in terms of I and j. So V means I would have to subtract my x's. Now here order does matter because when I'm drawing the vector, I'm taking direction into account. So I'd have to say the 0.2x value, which would be 2, minus this -2, and then I write my I, plus, I'm going to take my y's and subtract them, starting at the terminal point, 3 minus a -2, and then I'll write my j. So clean up these two numbers, okay? Vector V can be called 4i plus 5j. Now, if I wanted to draw that one, I would have to go up to 4 on my x and up to 5 on my y. Okay? I only need that one point, and then I would draw that one stemming from the origin. Okay? Now, being that we're drawing this by hand, don't freak out if you feel like, well, their lengths don't look perfect. You're drawing this by hand. If you're drawing it on a graph, it should look exact, okay? So you could see in general form, and we found the vector to draw it in standard form, okay? We sketched both. We found vector V in ij. Last to do is to find the magnitude. You have two options to find this magnitude. You can either use the 2 points and use the distance formula, or since you already have your ij unit vector, you can go straight. You already did the subtraction, and say that magnitude V, I can use Pythagorean and say the square root of 4 squared plus 5 squared, okay? And that will give me the square root of 16 plus 25 square root of 41 is my magnitude, okay? So we finished this problem. We have both sketches, general and standard, which is our ij unit vector. We wrote our ij unit vector, and we found its magnitude. All right? The rest of this lesson will be in a part 2 video. Stay tuned.